Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at wildcard masks and access control lists. We'll be discussing a wildcard mask overview, wildcard mask types, wildcard mask calculation, wildcard mask keywords, and then finally we'll look at wildcard masks in access control lists. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. The wildcard mask is used to tell us what parts of the IP version 4 address we want to pay attention to, what parts of the IP address we don't care what that value is. So there's part of that IP address we want to compare and make sure it matches. There's part of that address we don't want to compare. We don't care what that value is. Now, this is going to sound very much like the subnet mask. The subnet mask, once again, was that process of ANDing, remembering all the way back to our binary, where we wrote the IP address in binary, then we wrote the subnet mask in binary below it. Wherever there was a 1 at the beginning of the subnet mask, because the subnet mask is all ones followed by all zeros, wherever there was a 1, we wrote down those bits of the subnet mask, we wrote down those bits of the IP address. Wherever there was a 0 in the subnet mask, this process was an ANDing process. And what we have here is, I'm going to write an IP address here. I'm just going to put down 8 bits for the IP address. 3, 4, 5, 6, 7, 8. Then I'm going to write down a subnet mask in binary. And this subnet mask, once again, a subnet mask is all ones followed by all zeros. And what we did is the host portion and network portion was separated by the subnet mask, where we had the difference between the ones and the zeros. And that line draws all the way up here. So on the left part, this was the network portion, this was the host portion. And what we did is we ANDed these values together. And what it says here is when we say 1 and 1, or value, the first value and the second value. If both of those are 1, this was a 1 down here. If either one of these was a 0, so if we have a 0 and a 1, it turns out to be a 0. The only time we get a 1 down here is when there's a 1 and a 1. Otherwise, it's always a 0 when we're ANDing. And so the first one here is we have a 1 and a 1. 2 1s there, that turned into a 1. Then we have a 0 and a 1, that was a 0. Then we have a 1 1, that turns into 1. We have a 1 1 here, that turns into a 1. That was our network portion, signified by our subnet mask. Then we came to the host portion, and notice the host portion is all zeros. And once again, remember the ANDing. It has to be a 1 and a 1. If both of those are 1s, it will be a 1. But because we have all zeros here in the host portion and the subnet mask, it's going to be 0. So 1 and a 0. Are they both 1s? Nope, that's a 0. Then we have 0 and 0. Definitely a 0. Anywhere there's a 0 here, it's going to be a 0. And what this gave us here was our network address. The network portion followed by all zeros. And that was the ANDing process. Now, once again, this is subnetting. Wildcard masks are similar but different. They use the ANDing process. But after that, there is a huge difference. So it uses the ANDing process, that's a similarity, but then there's a huge difference. When we do a wildcard mask, the binary 1 here is equal to what we want to match, where the binary 0 is not a match. So the binary 1 was matching, and so in this this host IP address, in this network address, we wanted to match the host portion, right? We wanted to match that host portion. For the wildcard mask, it's the reverse. And what I mean by the reverse is the wildcard mask where there's a 0, it's a match, which is the opposite of the subnet. Where there's a 1, we ignore that. We don't care what that value is. Up here in the subnet mask, where there was a 1 here in our subnet mask, that's what we have right here. This was 1s right here. We cared what that was because we wanted that network portion. Now in a wildcard mask, we switch it. The other thing about a wildcard mask is the 1s and the 0s are in a different order. And so over here, I'm going to draw a big line, and then this is the wildcard mask. So we have a wildcard over here. I'm going to write that out, but you're going to notice it's different. That wildcard mask starts off as 0s and then ends in 1s. Starts off with 0s and ends in 1s. I'm going to write down our IP address. I'm going to use the same one we did on the left side. So I got 1011 1011. And once again, I told you it's an ANDing, so we AND them together. When we do our wildcard mask here, we start off, we have all 0s here in the wildcard mask. So basically, wherever there's a 0, when we AND them together with the IP address, we're going to get 0. So 1 and 0. It's not a 1 and 1. It's a 1 and 0 that gives us a 0. 0 and 0 gives us a 0. 1 and 0 gives us a 0. We have another one. But then, when we get into that last part of the wildcard mask, that's where we continue ANDing, but now we have 1s, and so our values may change here. And right here we have a 1 and a 1. So 1 and 1 gives us a 1, 0 and 1 gives us a 0, and then we have a 1 and a 1. And then this is our wildcard mask. This is our value for that, and that's how we get our numbers. Let's look at some wildcard examples here. Here we have the wildcard mask written out in dotted decimal notation. Here we have 32 zeros. We wrote it out in our dotted decimal notation for us humans. And what we're going to do is we're going to pay particular attention to this last octet. We're going to take this last octet and draw it out in binary, write it out in binary. And so having all 0s in the last octet is going to give us 8 binary zeros. Now, remember, in a wildcard mask, remember what they mean. The meaning here is the 0s we want to match. We want to make sure that we match those where the 0s are, and then we ignore where there's a 1. When we look at this last octet, we have 8 zeros. We want to match all the octets. First 3 octets here were 0s. And then the last one, we have all 0s. So the fourth one, we want to match all of these octets. Second example here, we have 00063. And what we did is we took this last octet right here, wrote it out in binary. That gives us 2 zeros and 6 1s. Now, once again, remember, 0s mean a match. And so what we want to do here is we started off with our 3 zeros in our dotted decimal notation. That means we want to match the first 3 octets. Then we have 2 zeros here. The left 2 digits here, they're 0s. Those are matching. That means we want to match the left 2 most bits of the last octet. And then finally, we have 6 1s. Those 6 1s means ignore the last 6 bits. And what we're doing here is we are comparing, or we're matching everything up to here. And so that first 3 octets gives us 24 bits. These 2 gives us this. We are matching a total of 26 bits. And so we are looking at the bigger networking portion. We're going to match those, and that's what we're looking for. Third example, we have 3 octets of zeros, and then we have a 15. We take that 15, convert it into binary. Into binary, we get 4 zeros, we get 4 ones. Now, looking at this number holistically, our first 3 octets here, we want to match them because those are zeros. Then we want to match the left 4 most bits in that last octet, that because those are zeros, so we want to match those 4. And then these last 4, we don't care what those values are. Looking at our fourth example introduces us to something that's unique to the wildcard masks also. Here we have 000.248. We take the 248 and we convert it into decimal. Notice the ones and the zeros. It doesn't always have to be all zeros to all ones. Now remember that. It doesn't have to be all zeros to start with, followed by all ones. It could be reversed. So we could have ones followed by zeros. And actually, you can mix them up because that's what we did here. If we look at the first 3 octets, our first 3 octets are all zeros. So we want those to match. We want these first 3 octets to match. But then we come into our 8 bits here. Our 8 bits have 6 ones and then 2 zeros. The 6 ones right here, we want to ignore them because, once again, we are ignoring where the ones are. We don't care what the values are in here. We just don't care. So we're going to ignore those left 6 bits, but then the last 2 bits are zeros in our wildcard mask, because once again, when you convert 248, this is what you get. You get 6 ones followed by 2 zeros. Those last 2 bits, we want to match those. We want to match those, and so that gives us matching the last 2 bits. And then finally, our one last case down here is we have 000,255. First 3 octets are zeros. We want to match the first 3 octets, but then a 255 here gives us 8 ones. These 8 ones, once again, we are ignoring our ones. We don't care what the value is in this last octet. We're just going to ignore any of the values in there. So we're going to match the first 3 octets and ignore our last octet. If you like this episode on wildcard masks and access control list, and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. This all helps support the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. We're going to take wildcard masks and we're going to start building some access control entries on that. And so what we're going to do right here, we're going to build an access control entry that only permits a host. So we're looking at a single IP address of 192.168.1.1. So we're only going to permit that one. Now, because it's only one IP address, what we have to do is we have to compare every one of these. We have to match every one of these 32 bits. Now, we are matching, and remember, in a wildcard match or mask, if we want to match, it's a 0. Down here in this table, we took the IP address here. Here's dotted decimal notation. We wrote it out in the 32 bits, 32 ones and zeros. Yes, we did put the decimal points in there to help us follow the lines a little bit better, but the computers don't even use those decimal points. They just see a string of 32 ones and zeros. So this is the IP address. They see the binary address right here. Then, because we are comparing all 32 bits, or we're going to match all 32 bits here, we need to put all zeros in here. That gives us our wildcard mask. If we put all zeros in here, that gives us a dotted decimal notation of 0.00000. 4 zeros. Like I said 5, I think it should be 4. Because we are matching every bit, we want to look at all 32 bits. And that gives us the addresses that are allowed through, and it's only one IP address. And how did we get that? Because there's a 0 in this wildcard mask right here, the first one is a 0, we want to match this. So it has to be a 1 here. Then the next one is a 0. It has to match this. It has to be a 1. The third one is another 0 or in the wildcard mask, but it's a 0 in the binary, so it needs to be a 0 down here when we're figuring out what our permitted addresses are. And as we work through, you can see that these are a direct match from the binary IP address above because we have all zeros in the wildcard mask. So as we work through there, it will be identical to that because we are matching all 32 bits. When we match all 32 bits here, we convert that into dotted decimal notation, and we only get one IP address. So if you see a wildcard mask here of all zeros, that means it's only this IP address that's allowed through. This is the only IP address that is permitted through. When we build our access control entry, because once again, remember, access control entries, a bunch of those make up the access control list. And so we have access control entries in there. How we build our access control entries is we start off with the keyword access list, then what number of the access lists are. You can have multiple access lists because you can have inbound, outbound, you can have it to all the interfaces. And so they all get numbers here. And then whether this entry here is a permit or deny, we want to allow that single host in here. And then we put in our permitted IP version 4 addresses. We put in this value. This value, once again, is based off of the matching of our wildcard mask and the address we were given. That number right here fills in right there. And then we put in our wildcard mask from right here. That follows in there. Now you're going to say, well, why didn't I put this one in there? Right now, because we're doing the matching of the wildcard mask of all 32 bits, these two answers are going to be the same, but in our next couple slides, you're going to see where it's a little bit different. And so it should be what you calculated here based off of your original IP information and the matching of the wildcard mask. In this example, we're going to create an access control entry that permits all hosts. So it's all hosts. So it's a range of addresses in the 192.168.1.0/24 network. So they give us a network address. If that host resides anywhere on here, we should permit it to go through our access control list. First thing we do is we start off with writing down our IP address. And we're just going to pick out an IP address. We'll pick out the first usable here, 192.168.1.1, and then turn that into binary. When we turn it into binary, we get our 192.168.1.1. That's what our binary number looks like. Now, we have to permit all hosts in this network. And so it's a /24. So our difference in our host portion and network portion is right here. That's a /24. Now, what that means is we have to match everything before this. We have to match here. We match this. And then after where the subnet mask is, we can ignore that. We can ignore this portion. And when we write out our wildcard mask, remember, 0 means we're matching. And so we start writing out our wildcard mask in binary. We are matching the first 24 bits, so we write all zeros in there. And then we are ignoring the last 8, and to ignore those bits, that's a 1 again. And so that's where we start putting our 1s in. In our wildcard mask, 0 represents we are matching. We are matching that corresponding bit. So the first one here, we are matching. We have a 1 up here. That gives us a 1 down here in our calculated permitted addresses. Then we have a 1 here. Carries down to 1. And then we have a 0 and a 0, 0, 0, 0, all the way through. We match these. So they have to match exactly of our given information up there. So that matches all the way through up until we have our zeros. So all the way through here was a match. Then, for where there's a 1, we don't care what that value is, so it doesn't have to match. That gives us our zeros. We don't care what that is. We just fill that in with zeros for our network address. And so that gives us our network address right here. Now, to build our statement, once again, we start off with access list and then the number of our access list, and we're permitting here. It's either permit or deny. We are permitting according to our requirements. We put in our network address. That's what we calculated right here when we did the calculation based on our matching. That value goes from right here up to there, and then we put in our wildcard mask. Our wildcard mask is what we came up here. That fills in there. So our command here, our access control entry that permits all hosts in the 192.168.1.0 network is access-list 10 for access list 10 permit 192.168.1.0, the network portion, and then the wildcard mask. Once again, wildcard, where there's zeros, we want to match it. Where there's ones, we don't want to match it. Now what we're going to do is we're going to kind of do the same thing, but we're going to put in a address range where it's going to be more than a Class C address. And so what we want to do here is create an access control entry that permits all hosts in the networks of 192.168.16/24. So it's a /24, so it's right here. And on the network of 192.168.17.0/24. So our network differences here all the way up through the .31. Now, if we look at our third octet, we go from 16, 17, all the way up to the 31. And that's what these 3 periods means here, all the way up to, so we include 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. We want to permit all of those to come through. Well, how do we figure that out? What we have to do is find the common numbers here between that. If we go in there and we look, a lot of times we're used to borrowing bits going to the right to make smaller networks. If we borrow, so going to the right, we make smaller. If we borrow bits to the left or take bits, they get larger. We can get larger. If we move over 1 bit, it will cover 2 additional networks. 0 to 127, 128 to 254. Move 2 bits over, 3 bits over, and finally 4 bits over. It will allow us to cover 0 to 15, 16 to 31. And so what we're going to have to do is come up with our network here of what's going to work and what our subnet is. And basically what we're doing is we're going to take an additional 4 bits from here. We're going to take an additional 4 bits from that third octet, from the right side of the octet, to allow us to what they a lot of times refer to as super netting, combining networks together, network addresses together. We're going to start down here with our IP version 4 address, 192.168.16.0. Convert that into binary. That's what we have right here. And then we talked about taking 4 bits. So our /24 is here. If we go over and take 4 bits, that will give us right here. That will allow us to go from .16 to .31 in this third octet. we created some super nets. Now, to create our wildcard mask, once again, we have to permit all of these hosts. So we have to compare the first octet, the second octet, and then the third octet, we have to compare the first four octets, or sorry, first four bits. But then after we do the first four bits, we don't care what the last one is. We can ignore those. So we wind up going 8 plus 8 plus 4 equals 20. The first 20 bits we're going to match, so that gets our zeros. The last 12 bits here, that is going to get our ones because we're going to ignore those. Don't care what the values are in there, because it could be any one of those networks, .16, .17, all the way up to .31. And the last octet could be anything. And so when we look down here and we figure out our permitted addresses, we start with the .16. If there's a 0 here, we have to match it, so we take the ones down. That gives us all of our values all the way up through here until we come to the ones. Then for the ones, we don't care what that is. So for the network portion, we're just going to put zeros in there. And that goes all the way up to the .31. Now, the trick here is how do we write that out in binary, or sorry, as our network address? You take the first network here that we've calculated out, and that is the number we put in our access control list. So we start off our access control list with the keyword access list, then what number it is, we're permitting again, and then this first network here comes up to here, because when we put our calculated wildcard mask in here of this network address is going to cover .16.0 all the way up to .31.254. So this is our command. Now, if this super netting, and I'll write that term down here, if this super netting was a little bit complicated, check out the other videos here that dealt with the IP addressing. We discussed super netting in detail. When you're working with wildcard masks, one of the most challenging parts about it is actually calculating that out. Writing out the binary of the IP address, writing out the binary of the wildcard mask, remembering 0 is matching, 1 is ignoring, coming up with that. For example here, what if we want to create an access control entry in access list 10 here to permit access to all users in the 192.168.3.0/24 network. You have to write this out in the binary. Then you have to remember that the /24 here, at least for me, is easy to remember. The subnet mask is 255.255.255.0. You got to remember that, and then we can convert that into binary. There's a shortcut. What you can do to figure out the wildcard mask is subtract the subnet mask in decimal dotted notation. That's the 255.255.255.0 here. You can subtract it from all 255s. That value will give you your wildcard mask. So from here we have 255, 255, 255, and then we're going to subtract out 255.255.255.0 from that. Here, when we subtract 255 from 255, that gives us a 0. 255 from 255 gives us a 0. 255 from 255 gives us a third 0. And then in our fourth octet, 255 minus 0, that gives us 255. So our wildcard mask here is 0.0.0.255. And then we can build our access control statement, or our access control entry. So we have our keyword of access list here. We're going into list 10. We're permitting anything from this network. And once again, where did we get this value from? That was given to us right here. And then we put in our wildcard mask. Our wildcard mask we calculated right here. To make it a little bit more clear, look at this. I put up a little diagram here to show you how those columns line up. And once again, we are starting here with our 255. So you start off with a string of ones, convert that all into dotted decimal notation. So you got 255, 255, 255, 255. Then you write down the subnet mask below that and you subtract them down. That's what we did to calculate it here in our first example. So we got 0.0.0.255. That gave us our wildcard mask. In another example, we do the same process. We take our 4 255s and then we put the subnet mask in. Here we have a subnet mask of 29/29. When you convert that to dotted decimal notation, 29 ones followed by zeros to fill in up to 32 bits, you get 255.255.255.128. Go through, subtract these. So 255 minus 255 is 0. 0, 0, and then finally in the fourth octet, 255 minus 128, that gives us the value of .127. So our wildcard mask right here, 0.0.0.127. Okay, in our second example, once again, we want to control an access or create an access control entry on access list 10 to permit for the 14 users in this particular subnet. Here's the network address for those 14 users. Here is our /28 in a slash notation. If we convert that slash notation, we get 255.255.255.240. We can subtract that from 4 255s. We could write that down here. 255.240. Subtract that out. That gives us 0, 0, 0. And then 255 minus 240 is 15. That gives us our wildcard mask of 000.15. We can then build our statement. Keyword access list. Access list number 10, permit our network address. Once again, our network address came from this information right here. And then we put in our wildcard mask, which came from right here. And here in our last example, we need an access control entry for access control S to permit only the networks of 192.168.10.0, 192.168.11.0. What we're going to wind up doing is this super netting again. If you're still a little fuzzy on super netting, look up some of our previous videos. We cover it there. But we're going to wind up super netting and borrowing 1 bit. So here, these were /24s. What we're going to wind up doing is using a /23 with that first network address. And so we can summarize these two networks as 192.168.10.0/23. And then that subnet mask, when we convert that /23, that goes into a 255.255.254.0. We can go ahead and subtract that from the 4 255. Gives us 255.255.254.0. Subtract that out, gives us 0.0.255 minus 254, 1. And then 255 minus 0 gives us 255. So our wildcard mask is 0.0.1.255. We can go ahead and build our access control entry, starting off with the keyword access list. For access list 10, we're permitting. Then we put our network address in here. Once again, our network address came from when we summarized our networks together. And then we can put in our wildcard mask. Once again, our wildcard mask came from when we did our subtraction. So the calculation can be done with that subtraction where you put 4 255s, put the subnet mask, subtract those, that will give you your wildcard mask. When you're using wildcards, building your access control entries and your access control list, you can use 2 keywords. Those 2 keywords are host and any. When you are matching a host, you are matching a single IP address. You are going to match all 32 of those bits. And remember, when in a wildcard mask, zeros are matching. And so if you're matching that IP address, you have to have all zeros. Now, the operating system knows if you're going to match that IP address, you're going to put all zeros in there. You could replace that with the word host. And what that means here is host is equal to 0.0.0.0. Those are interchangeable to the operating system. And a lot of people think or consider that a little bit easier to remember because you're matching a host. The keyword of any. This mask says ignore the entire IP version 4 address and accept any address that's being sent to me. We're going to ignore every one of those 32 bits. Now, to ignore every one of those 32 bits, we have to put a 1 in there because in a wildcard mask, a 1 means ignore. So we're going to have 32 ones. Change that into dotted decimal notation. That comes out to be 255.255.255.255. 32 ones altogether. You can interchange the quad 255s with the keyword of any. So you can substitute these 2 words in these particular situations, and the operating system on your router will understand what you are doing. It was my pleasure to bring you this wonderful episode on wildcard mask in access control list. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all of these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.